Hi, everybody. Thank you for joining us. Good morning, good afternoon, good evening, wherever you're joining from. Thanks for being here. I'm Alex Delipalta. I am the Communications and Engagement Officer at the RDA Europe office, and I am working on communications for the WorldFAIR project. So this is another webinar, part of our series on presenting project outputs. Today, we will hear from chemistry and nanomaterials. Before we begin, very quick housekeeping. This webinar is being recorded. You will all receive the recording after the webinar, and it will also be published on our website and on our YouTube channel. You can post your questions in the chat during each presentation. There will be a Q&A section both after each presentation and at the very end, so feel free to add any questions. Now, our webinar series. So we've already held 3 webinars, including our opening session. Today we are here. As I said, we'll hear from chemistry and nanomaterials. Next week, we have another webinar coming up from biodiversity and agriculture. In October, we will hear from population health and urban health. In November, we have our disaster risk reduction webinar, and in December, the second webinar from cultural heritage and social surveys. So join us. You can find the recordings of our webinars and upcoming dates on our website, which is there at the top right of the screen. And I will also put it in the chat after my presentation. So today we will hear from Leah McCune from Cornell University. Leah has a background in nutritional biochemistry and in library and information science. She's a chemistry librarian at Cornell since 1999, supporting information discovery and data management needs for the research community. She's an active contributor to national and international data initiatives. She's founded the Chemistry Research Data Interest Group in RDA, and she's organizing thematic programs on chemical data standards. Leah is the chair of the Committee on Publications and Cheminformatics Data Standards in IUPAC, and she's responsible for the design and implementation of digital standards. So today's presentation from Leah will be on aligning IUPAC standards with FAIR data practices. Some information on the chemistry work package. So the work package aims to align chemistry data standards with the FAIR data principles through development of guidelines, tool and validation services, by addressing gaps in standards that currently restrain chemistry, and by engaging critical stakeholders in the adoption of standards and best practices. Leah today will touch on the digital recommendations for chemistry FAIR data policy and practice, which is the first published report by the chemistry team in WorldFAIR. The report reviews some critical and persistent issues around documentation of chemical information and considers requirements to achieve fair sharing of chemistry data in ways that are reliable, interpretable, processable, and exchangeable. Next up, we will hear from Professor Isolde Lynch from the University of Birmingham with a background in chemistry. She's the chair of the Environmental Nanosciences at the University of Birmingham. She has pioneered the concept of the biomolecule and environmental coronas and the development of enhanced understanding of the interactions of nanoscale materials with living systems. Isolde has developed tools and approaches to support researchers with data management and verification of nanosafety data, including leading the extension of the IUPAC identifier for chemicals to cover nanomaterials. Isolde is the co-lead on FAIR data in the 400 million Partnership for Assessment of the Risks of Chemicals, or PARC, and she's a highly cited researcher and a very passionate advocate of women in STEM. So Isolde will talk about the WorldFAIR nanomaterials towards unique representation and identification of nanomaterials supporting FAIR data practices. So again, a few words on the work package and the work that they're doing. So the goal is to pioneer practical real-time solutions to enable FAIR nanomaterials data through organizing and collating existing materials, tools, and training to support FAIR nanomaterials data, by addressing gaps in standards, and by driving a change in the mindset of researchers and stakeholders regarding the value and benefits of data verification. Isolde will also talk about the first report published by the Nanomaterials work package, the Nanomaterials domain-specific verification mapping. This deliverable presents the initial FAIR implementation profile, which describes the current state of the field and discusses domain-specific challenges relating to nanomaterials and its FAIR landscape. And I will post the Zenodo links to both deliverables that will be discussed today. So that's it from me. Thanks again very much for joining us, and I will now give the floor to our first speaker, Leah.
Thank you very much, Alex. Let me just, oops. There we go. Put that into full screen mode. Okay, great. Can you hear me?
Yes, perfect.
All right. Thank you so much. As Alex mentioned, I'm the Leah McEwen. I'm chair of the IUPAC Committee on Publications and Cheminformatics Data Standards. And in this role, I have the great pleasure of working with an amazing community of volunteers in IUPAC and also broadly in the chemistry community to work on data and information exchange in chemistry globally. So it's just sort of a hand waving. Chemistry is everywhere. There's probably facets of chemistry in most, if not all, of the sustainability goals. And the great thing about some of these initiatives is they're bringing many disciplines and perspectives and active groups and stakeholders together worldwide. And the fact that we have an opportunity to put chemistry in a position of supporting these projects forward is really exciting opportunity for us. So IUPAC is the standards organization. It's been around for over 100 years, and it's been working on defining a common and systematic language for chemistry for a long time through chemical representation, parameters around chemical properties, core concepts in chemistry. And there are dozens of different kinds of standards and outputs that are developed around these core pillars. And IUPAC has been stewarding these for a long time, but most of them are in an analog form and they're scientific oriented definitions and don't necessarily always address technical parameters and constraints in our digital environment. So we've been working in IUPAC and in collaboration with the broader community to develop machine processable representations and guidance on how these can be incorporated into some of the FAIR workflows and other data activities. So the goal for this project, when we were invited to join and host the chemistry case study for the WorldFAIR project, was to kind of explore what it's going to take to align some of these standards with the FAIR principles. How can these standards actually support the implementation of FAIR into data sharing and workflows? And if we kind of look at some of the functionality of FAIR, thinking about how some of the current standards that exist in chemistry, both those held by IUPAC, but also those that are in development in the broader community might support this, where the gaps are, where we have more opportunities, and in particular to collaborate across disciplines and across sectors. So this is going to be a whirlwind talk, so forgive if you want to know more, read the report. So taking a quick look at crystallography, which is often pointed to as a mature case study for data sharing, where data is shared in repositories in standard formats and validated and available to the community for further reuse is sort of a regular practice. There's a lot of stakeholders and activities and soft infrastructure, in particular through standard vocabulary, standard formats, as well as identifiers, and a lot of these other key concepts that emerge around FAIR have been maturing around this community for some time, and this has kind of been a model for us when we're thinking about what we need to put together to support FAIR data sharing in other disciplines, scientific disciplines. In chemistry, we have an interesting challenge. Sometimes we have many options for how we notate and represent the information that's critical to share. And sometimes, but on the flip side, even some of these representations that you're seeing here for discrete organic molecules might be limited for other applications, including materials, more complex molecules, more active forms, radicals, et cetera. And actually, Isolde, who's following me, we will be speaking more specifically about this challenge in the nanomaterials space. So we have both a richness of opportunity and also a limitation challenge here. Looking at chemistry data, chemical properties. It's also quite complex. A lot of facets will influence a property of a chemical, different conditions that the chemical is in, the purity of the chemical. And there are many different ways that have been defined over time for expressing units around many of these different properties. This is just literally a very incomplete snapshot of what solubility data kind of looks like. This data point was reported in the literature in the 30s, and it was extracted here into the IUPAC solubility data series to be compiled with very similar data points published in other articles and evaluated as to the range of error in taking these kind of measurements, and that's very informative for reusing in models that need to work with a high level of confidence around this property, the solubility property. So there's a lot of need for this data. But there's a lot of places where there can be variability in the reporting. And as of yet, in fact, even for IUPAC, the process of reporting this data, both in the initial literature and then pulling it back out of the literature and compiling it, is all very analog. And this is right out of the PDF solubility data series volume 60. In addition, we also in the report looked at what's happening around data reporting guidance. That data is obviously a very active topic right now, and even since the time that we published a report, which was pretty much finalized by the end of May, there have been several other more reports that we can continue to look at around being AI ready and other future directions in different places around the world. So this continues to evolve, but there's many different levels and focus areas that have looked at what data sharing means, and in particular in chemical sciences, starting from overarching goals, but also all the way down to how do we actually put this into practice. We took a kind of a broad look at this, looked at some of the themes that are arising out of this, and a role that IUPAC has played for a really long time is to really focus on what's really important for describing the data, and that as people are needing to report data in a lot of different contexts, some of which are described in these studies here, they can make decisions about what's important for their use case, what's important for their business case. We can't really dictate the policy because there are just so many different use cases and so many different situations where chemistry data is used. But we hopefully can provide some guidance on what is important about making sure that chemistry data is clear and unambiguous and reusable. And so this is just a overview of the table of contents of the deliverable that Alex mentioned. It is available on the WorldFAIR Zenodo. And we took the landscape review. I sort of mentioned a couple of highlights there just now. We also looked at some specific, starting to drill down into some of the opportunities for starting to implement some of these standards more directly into frameworks that are evolving for the digital space. We also looked at how chemistry is intersecting some of these other disciplines. And again, Izzat will speak a little bit more to this specifically about nanomaterials in a few minutes. I really just want to emphasize again that the vast majority of the community of researchers are utilizing tools and information systems that incorporate or could incorporate a lot of these standards, the technical standards and the scientific standards, to facilitate all this. So while researchers are an extraordinarily important stakeholder in all of this, so too are those who work on these systems and these tools, these repositories, the ELNs, all of it. And it's that community that we also really want to engage. And in chemistry, we have a pretty robust chemical information professional community that's been built up over time as these tools have already evolved in our community. And this is definitely a very important topic for that community on behalf of the broader chemistry community and the broader scientific community. Tell me when to stop, Alex. I'm just going to talk. One of the things that we looked at, we kind of thought a lot about what IUPAC standards, how they focus on describing the nature of chemistry and chemistry data, and kind of reframed FAIR a little bit in terms of thinking about where do you start? What's the most important place to think about first? And it's most critical to think what is the necessary information that you really need to make sure you're describing the samples that you're working with and the measurements that are taken on them as unambiguously as possible. And while you may be using the measurement in a very basic way, if you're sharing it to be reused by others, they may need to use this information in a more robust way. So trying to consider that in your documentation, and then aligning that information with both scientific determined standards and then also technical standards so that they become processable. And then at the end of this, what's the information that we then make available so that people can come and grab that data and actually share it and move it system to system. So I feel like it's really definitely a phased approach here. And we've started looking at some of the standards activities that are happening in IUPAC and how they might support some of these activities. And we go into a little bit more depth on this in the report. We also have started looking more specifically about, exactly, this is aligning IUPAC with FAIR again. How do some of the different projects in IUPAC actually support some of the particular motifs in FAIR? This is an aspect of the WorldFAIR project. They're doing a FAIR assessment. And so this is our participation in that. In addition to looking at how IUPAC standards can support FAIR functionality, we're also looking at those standards themselves. Are they machine readable, processable? Are they programmatically accessible so that they can be utilized in digital workflows? And so we want to do this. We've done one example with the Gold Book, which many of you may be familiar with. It's our corpus of terminology. It's starting to pick up a lot of activity and attention. But we have many other standards projects that need this kind of review, and we need to be thinking in IUPAC about how we manage these standards to make them more accessible for the broader community. We've also been starting, as part of our conversations with some of the other disciplines, we're starting to think about what are the aspects of chemistry that intersect with those other disciplines. Where are these points where, when we're trying to combine heterogeneous data from different disciplines around different kinds of measurements, are there points of integration, so that we can create compiled data sets from interesting studies, and so here are some of the points around substances and properties and, basic things like units and samples is definitely a very important shared concept across a lot of different disciplines. And that I showed the CDIF chart there. CDIF is cross-disciplinary information framework. That's an aspect that the WorldFAIR project at large is developing in conjunction with a lot of these discipline-based case studies. So we're trying to work on how we would approach, pulling together a lot of the ways that we notate some of these different integration points so that different use cases and disciplines can use them as crosswalks. Other areas where we're working on cross-domain interoperability, I mentioned samples. The provenance and identification is very important to us. So we are collaborating with a number of the work packages on a Birds of the Feather session coming up at the RDA International Data Week conference in Salzburg at the end of October. We're also very keen to understand and be able to articulate out a lot more with more nuance around how molecular entities and samples and systems and conditions and measurements all map together. There's going to be an in-depth workshop hosted by the WorldFAIR project with several of the domain groups, again, looking at some of these core metadata frameworks, and we'll be exploring that in further depth. And another area that's really starting to take off is how we use authoritative terminologies in developing a lot more semantic assets to support data representation. There's going to be an Ontologies for Chem workshop, which is pulling together a lot of activities that intersect with chemistry, terminology and ontology workshop that's being hosted by NFDI for Chem in October. Also on this morning, I was just on a call with some colleagues who are proposing a new working group in RDA to harmonize terminologies and approaches to ontologies for FAIR materials data, and they're very interested in working with us in chemistry in the Gold Book. And also just want to mention, relative to my conversation earlier about how we support the community starting to think about incorporating chemistry guidance into their work. There's a workshop also being hosted by NFDI for Chem in early November with editors, journal editors, as they're thinking about what kind of data gets reported in their journals and how to support more accessible workflows for that data. And let's see. I just wanted to call out that 2 other things we're thinking about is sustainability. We IUPAC haven't had a really well-developed infrastructure for supporting digital standards development. So how can we set up a structure that supports that and is supported? I think this is a challenge a lot of places face as this area really expands. So we are actually, the Pistoia Alliance is hosting us to do a sort of an in-depth workshop on value propositions and sustainable business models for some of our digital standards. And we're hoping to kind of take some of the lessons from that workshop and share them around. Also, we really consider this workshop an incubator or jumping off point for IUPAC. So we will be furthering our content and our study on the D3.1 report so that we consider that a living document. And we will be expanding on our approach for how to work with our standards and the community collaborations. So I just wrap up here. We have 3 main deliverable areas. I was mostly focusing on the 3.1 report, the first version of which has just been published a couple months ago. And we have 2 other deliverable areas that are in progress. You can look at early prototypes now. These are much more hands-on. Most of the information is available through Jupyter Books, and then you can go from there to try things out and provide feedback. And I just want to acknowledge a lot of collaborators, a lot of great initiatives going on in this project. So thanks everyone for the opportunity and for bringing your expertise to the table.
Thank you, Leah. Any questions at this point, Leah? No? I can call for questions. I think if we don't have any at this point, we can proceed with Isolde and then have a discussion at the very end.
Okay.
Great.
Let me share my screen. Okay, hopefully that's visible now. There we go. Okay, so thank you very much, Alex, for organizing us, and thank you all for joining us here today. Leah is always a hard act to follow, so but on the other hand, she covers a lot of the background information that means I can dive straight into some of what we've been doing in the nanomaterials case study. And we've really been focusing on moving towards unique representation and identification of nanomaterials and building tools to support fair data practice. And I think a really key piece of what we've been working on is really trying to take it also from the perspective of the data generators. So trying to bridge the gap between the very technical aspects of FAIR and the day-to-day, how do I do it as a researcher? And just before I forget, or in case I forget, just to acknowledge that Nova Mechanics and 7+9 are also very central to this case study. So nanomaterials, really the challenge we've had with them and why they've been a focus area for research over a long number of years is that they have properties both as chemicals and as particles. A lot of the work that we're doing with them is from the perspective of how we regulate them. So looking at them in terms of how we assess their safety and how we ensure that we're developing these materials which have as many application areas as chemistry itself. And as part of that, then REACH, which is the legislation for the regulation and assessment and authorization of chemicals, considers in the EU, considers nanomaterials to be chemicals. So when REACH came out in 2007, it was just before a lot of the concerns or the potential concerns around nanomaterials as having different toxicity maybe than bulk materials. So they said that REACH still covers nanomaterials because they are chemicals and they're composed of elements from the periodic table. But they also have then properties related to the fact that they're particulate, they're an entity. So, they don't follow equilibrium principles to the same extent. They, some of them may dissolve, some of them may interact with their surroundings. So they're very dynamic and they have an entity that moves. So the concentration locally can be much higher than an equivalent if it was a soluble form. And all of that over the last 10 or more years has led to, for example, the European Chemicals Agency introducing the concept of a nanoform. And this is really a way to distinguish whether one titanium dioxide, for example, one titanium dioxide nanoparticle is the same as another. So in terms of its size, in terms of its shape, in terms of any surface coating it might have, in terms of its crystal structure, and so on. So the idea being then that instead of having to individually register every single potential variant where the size, as we know, a size distribution or a shape distribution, these are actually ensembles. They're not individual. So you'll have we'll have the whole distribution. So the idea now is that if we can demonstrate that they are sufficiently similar, that they behave in a same way, we can classify them as a set of nanoforms. And of course, being able to describe and represent that is critically important. And that's what we've been trying to do in large part in this case study. But before that, then, I just very briefly say the goal of the nanomaterials case study is to pioneer real-time solutions to enable FAIR nanomaterials data. And I'm going to talk a little bit about the FAIR implementation profile, which is a tool that has been developed by the WorldFAIR Foundation. And it's a way really to map out what the community has currently adopted as its best practice. And that is sort of a reflection of where the community is now. And then you can also say, well, these are the gaps, these are the sub-principles of the FAIR principles that we don't yet address and therefore that we need solutions to. And this then is what's called the 2B FIP or the aspirational FIP. So a large part of our report, and the link is here, was looking at where we currently are for nanomaterials, what tools are available, what solutions are available, and what we're currently doing. And in some ways, nanomaterials are quite far along in the thinking about FAIR because we are highly interdisciplinary. We have had a very strong push from the European Commission, who's funded a lot of the research to make our data fair and reusable for different purposes. So to be reusable for regulation, to be reusable for read across and prediction, and so forth. So the first step we did was, so this is the link to it in the Zenodo under the WorldFAIR. So you can see it there. And I know Alex will put the direct link in as well. So the first thing we did in the same way as the chemistry case study did was we put together a sort of an inventory of the resources. So we mapped out what was already there. And WorldFAIR case study on nanomaterials came from a previous project in large part called the Nano Commons, where we had been trying to develop this idea of community of practice, and resources that were developed in multiple projects could all come together. And we were also thinking a lot about the data life cycle, and instead of having the sharing of the data and the preserving of the data being things that happen at the end of the project, when for example PhDs and postdocs are moving on to their next roles and you're trying to extract data out of them to put in a repository, to actually move sort of the consideration of the data management and the verification of the data to the point somewhere between the planning and the implementation of the experiments. So, and Leah alluded very briefly to electronic lab notebooks, for example, is one method there, that if you're already capturing the data in electronic form and already aligning it with harmonized templates, for example, or with ontologies, you're already a long part of the way to where you need to be. So this inventory of resources is described in the in the deliverable, and then just some examples. So there's some basic information and some links to why you might want to be fair, how you begin, all sorts of links also here to WorldFAIR and what WorldFAIR is doing. So our case study, our first FIP, and enabling people to comment on our FIP, and so on. And then we get into some of the detail of the FAIR implementation profile, which, as I said, really is this inventory of what the community is currently doing. And really, the FIP is developed by the WorldFAIR Foundation. It is really trying to focus on making things machine actionable. So not just that humans can interact with it, but also that it's machine actionable. And what they've done that it has been really helpful, in my understanding at least, is they've sort of split the sub-principles into ones that are technically focused, where you need an infrastructure and it's where the repository or the database needs to agree the standards or the approach. And then the ones in blue are the community ones, because we keep hearing that, okay, what you have to do what the community does. But if you don't know what your community does, or you don't know who your community are, and you can't find what those community practices are, it's difficult then to implement it. So we've really been in the Nanomaterials project focusing on these domain-specific aspect. So what are our existing ontologies available for nanomaterials? What are the metadata requirements to be able to reuse some of our data? And we describe in the deliverable then the current status, the where we are. And one of the big challenges, and I alluded to focus on how people can put this into practice, is that it's happening in real time. So FAIR itself and our understanding of FAIR and our tools for making data fair are being developed in parallel. So, and I've heard it described as we're building the plane as we're flying it. And I think that's one of the really big challenges that experimentalists face, that we're telling them they need to do this, but we don't yet have all the tools to help them do it. Or the tools are a bit fragmented, or they rely on Sparkle queries or GitHub repositories or Jupyter notebooks and things that are completely alien to your typical wet researcher, your bench researcher. Building on that, then, we've just had a paper come out that tries to pull a lot of this together, and we're sort of trying to develop for nanomaterials metadata on the fly solutions. So how we can manage to bridge across the different silos and make a much more responsive and dynamic and on the fly approach. So nanomaterials are a good case study in this sense because they're so interdisciplinary. We bring together, for example, people doing synthesis, people doing characterization, people doing toxicology, people doing environmental exposure, and now more recently then, safe and sustainable by design materials, green principles, all of that. So in the paper, as we were pulling together the existing resources, we sort of tried to frame it around two hypotheses that we could, that if we could think about it from the perspective of the data provider and the perspective of the subsequent data user, and see what the challenges are, see where they intersect and where we can tweak our existing solutions to sort of bridge those gaps and be accessible and usable to both communities. And it was the comments from the reviewers were really quite insightful, and what they said was that they hope that it gets out of the FAIR community and into the actual nano community. And I think that's one of the challenges, that we often have the feeling that we're talking to ourselves, not talking to ourselves, but talking to the people who already know how important it is to be fair. But how do we take that extra step and go to the people who are the data generators themselves? And Leah also mentioned the cross-domain interoperability framework. So we try and put our nanomaterials case study in that context as well. So things need to be domain specific enough to be useful, but also designed with interoperability in mind, and transferability to other domains as well. So we feel that most of the things we're developing are applicable much broader than nanomaterials, and hopefully will be picked up in other areas as well. one of the big things we've been working on, and I actually have a really guilty conscience about this one. I almost took the slide out because I feel so bad about it that I haven't actually pushed it forward over the summer. But we have been working a lot towards an extension of the INCI, the identifier, the international identifier for chemicals, towards being able to also describe and represent nanomaterials. So we had a paper already in 2020 about it. And then we've been working with IUPAC and CODATA and the INCI Trust to formalise it as a standard. And we've made a lot of progress. And actually, the version that I'm showing here is an older version of it, but it's in the format that Leah has already shown, for example, for chemicals. So it allows you to sort of see where we're going a bit, that we need, for a nanomaterial, we need to think about the different layers, because it's often not just one material. It might be a titanium dioxide core, but it might have something else, shell, it might have an aluminum shell, or it might have something else. So we need to be able to list the different chemical compositions. The other thing that's really important for particles is you'll talk about a nanoparticle, or a nanoparticle which has 3 dimensions in the nanoscale, so it's typically reasonably spherical. But then you might also have nanotubes or graphene sheets and things. So the morphology is really important. The size and the diameter is critically important, because that tells us whether it can, for example, interact with a cell or not, or if it's going to be able to move into cells and into organisms. And then the crystal structure I already mentioned. But we have been doing a lot of work. We've been working very closely with the mixtures working group for INCI, and with others as well. And we've sort of come up with a few conventions that we will introduce for the nanomaterial standard. So, for example, we'll put N before the component to distinguish that it's a nanomaterial component. We will continue to use the standard INCI strings for surface ligands, and they will be listed alphabetically. We have made a change to how we're going to represent the size. So we're going to use a coordinate system with the internal, the core, the very center being 0, 0 and working out. We'll have probability distributions because they're not a single entity, it's a group identifier. And then we also have spent a lot of time thinking about how we differentiate connectivity. So whether a surface is chemically attached, whether it's physically absorbed, what chemistry changes and things. So and we're just finalizing the case studies around it now, so we will be submitting it very shortly as a standard. Other ongoing things, and I'm conscious of time, so I've said that we're trying to make it as practical and useful for researchers as we possibly can, and particularly for researchers who are not familiar with GitHub and things like that. And one of the approaches that we've been looking at, because it's kind of just click and connect, is looking at 9 workflows for how we can verify our workflows. So how we can, for example, use then our INCI and our NINCI to search the database, to pull down the materials that you want, to integrate different types of data, and then to do functions like cleaning up the data, gap filling, and so forth. So that's a work in progress, models and predictions. So again, we have a lot of tools that build on nanomaterials data sets for prediction of properties or prediction of effects, and how we can also make our models fairer is a next step. So in summary then, and the take-home messages, and hopefully I've inspired you to go and read the document, is that we have collated the existing materials, tools and training to support FAIR for nanomaterials, with the aim of really trying to provide some practical guidance. We are addressing the gaps in the standards. So, for example, the extension of the INCI to represent and identify nanomaterials. And we're really trying to focus on the fly tools and to reduce the disconnect between data generation and data management. And by default, then hopefully the disconnect between the data generators and the data users. And part of that, as I said, is really trying to drive a change in the mindset of our researchers and stakeholders regarding the value and the benefits of verifying their data. So currently it's sort of, we archive the data and that's it. We just, it's there and you can get it, but it's not really a dynamic interaction such as you would need for predictive modeling or materials design or so forth. So really trying to make it a much more dynamic, real time. And part of that is getting over the barrier of, oh, but what if somebody scoops my data and does something with it that I didn't think of, or they get their paper out before I got mine out. So, I mean, there are challenges and barriers. And also then that the outputs are transferable to other interdisciplinary domains and are aligned with the cross-domain implementation framework. This is not something we can do alone. So obviously I just want to acknowledge, in addition to the core group in the case study, we've also had project consortia, including Nanocommons and Nanosolvit. A lot of the work is now being further developed in Park and Macrame. There's also the Advanced Materials Initiative and the WorldFAIR Foundation, the European Materials Modelling Council, CoData, and so on. And thank you for listening. I hope that's been useful.
Thank you. Thanks a lot. We do have a question in the chat for you from Ahmad Madavi, who is asking, with the speed that nanomaterials are used in developing countries, including the agri-food sector, what global watch organizations are responsible to control this?
That's a really good question. And I mean, certainly nanoagriculture is one of the hottest areas, I would say, at the moment, even just from an editorial point of view. So I'm an editor for the journal ES Nano, and I would say easily half the papers we're getting currently are nanoagriculture. So I would say the WHO has been generally quite active on nanomaterials and sort of, looking at safety overall, but also probably the FAO, the Food Standards Organizations. But I'm not sure that anyone is specifically looking. Yeah, I would say that probably is somewhat of a gap that at the moment, EFSA, so that in Europe, the European Food Safety Authority has done quite a lot of work on considering the implications of nanomaterials in food and feed, and they have reports out on that. But at a global level, I'm not quite sure, but it's a really important question, I think.
Thanks, Isolde. Ahmad, if you'd like to add something, please feel free to unmute. So in the chat, it is, yes, please go ahead.
Oh, okay, thanks a lot. I mean, as you mentioned, is a partly of the job of the toxicologist. And we've been discussing all these issues of toxic pollutions around under SciCam and Earth. Right now, today, we were all the day involved. And I'm really always thinking about all these nano, particle formulations in agri-food, because partly of my studies goes back to the agriculture and food, and then so I'm always thinking that do we need really, because I followed it since 5-7 years ago, and I found that nanomaterials are good for some parts, sections of them. But in agri-food, anyway, I am always not sure that and about how much regulation do we have.
Yeah.
From EPA, I was receiving some news during the past 6 or
so ECHA wouldn't specifically deal with, so nanomaterials in food and feed come under EFSA. So perhaps have a look at some of the EFSA reports. But I think, a key piece, obviously, to connect it back to what we're talking about here in terms of FAIR, is the more accessible and reusable and findable, we can make the data sets around nanosafety and the dossier. So part of what we've been doing also is, aligning the ontology for the harmonized reporting templates, and trying to present our data in a way that is then useful for this reuse by regulators. So I think, the nanomaterials case, I mean, agriculture is maybe something that we could pick up as an area where this would be really, really useful. And I think connecting it maybe also to what Leah was saying about the Sustainable Development Goals, where, feeding the world is obviously a critically important thing to do. And nanomaterials may be able to help there in terms of as an alternative strategy to gene modification and CRISPR and things. So, yeah.
Yeah, I just want to reinforce what you just said, Isolde, about making the connections with the reporting and regulatory agencies, and ECHA is one. That in addition to the nano agriculture area, there's many other areas that they require reporting in that intersect with materials and chemistry, and connecting. If we can learn how to connect with that, with their requirements, I think this could really open up a lot of information flow. I think another area, in addition, that's also a little bit obscure is the UVCBs, the unknown and variable composition and biological and reaction products, all those things. That's another area that's really hard to break open, but is so persistent in communicating, materials and chemicals of concern.
Yes. Yeah, exactly.
Thank you both. Thanks, Samad, for your question. Do we have any further questions for Leah or Isolde? You can either raise your hand or post in the chat. No? I wonder if there are no questions at the moment. I wonder if perhaps we can talk a little bit about how your case studies and chemistry and nanomaterials, how you guys work together within the project. Any potential for collaborations, for synergies, any work you're doing as a joint effort, talking about cross-disciplinary applications of your work?
Well, I mean, I think even just from Leah's couple of slides, there were already several things where we are collaborating or will. So Leah mentioned the upcoming Birds of a Feather session on defining a sample. And I think that's something that has already made a really strong connection between chemistry, nanomaterials, and geochemistry. So interestingly, we sit in between those two, which is because, in some ways, nanomaterials also have a lot of things in common with minerals and rocks and things there. So that Birds of a Feather session, I think, would be really, really a nice demonstration. And it's things like thinking through how we might differentiate the carbon that might be in natural organic matter or biochar in the field versus the carbon that might be in a graphene sheet or a nanomaterial versus the carbon that's in the cell that we're looking for it in. So and how we describe all of those and differentiate and because they'll all come back to it's the same element, but it's just with such a diversity of forms and potential impacts. And then I guess you mentioned just at the very end, Leah, which you can maybe pick up on a bit more, the ontology for materials. I think that's super exciting, and we would love to be part of that.
To pick up first on the samples, I think there's the nature of the samples, but I think another persistent, interesting issue is what are the parameters around the sample, right? And I think this is something you're getting at, is you need to describe it in all these ways to delineate that this is the specific material that you're studying or that relates to this information or this data. So and I think that's definitely an interesting challenge that crops up. You mentioned geochemistry as well as nanomaterials, but also in the biological communities. One of the other groups that's participating in this is around pollination, actually, and so they have the sampling of different pollinators, but also their target plants that they're pollinating, and what's the relationship between these different types of samples. It's really fascinating. So I'm really looking forward to that Birds of a Feather.
Me too.
for the ontologies, I think, the materials, we had an interesting discussion this morning, and Stuart Chalk's also on the call, and I had to get off early, so I didn't benefit from the whole thing. Oops, sorry, I just had a water spill all over my desk. Sorry about that. Core concepts around materials. I think some of the things you were already commenting on, Isolde, in terms of what you have to do to describe a material. I think those are some of the things, and if they can be defined, what is a material, defining the parameters on that, so that as you're implementing things like NNCHI or a data model, it's clarified in those definitions. I think it's going to be a really interesting space that develops there. Okay, so Fatima's posted a question for me about the cookbook. Yes. I had actually requested, we're not going to talk about that here, but Stuart, maybe you can think about chiming in here as well. So one of the outcomes that we're working on, and this is aligns with Isolde's very good point, that that this is all, first of all, this is the whole thing is a moving target and evolving as we speak on the one hand, and on the other hand, it's a lot of change in practice for all of us across our workflows, and in particular, those who are generating data and who are focused actually mostly maybe on the research that they're trying to do and the grants and papers that they're trying to write. How can we support them in learning and engaging in these workflows? And one of the things we're trying to develop in the chemistry project, I didn't speak to it much in the talk, is what we're calling a cookbook. With the idea that we could include actionable, small focused actions in that for people to try. There's demonstrations or to evolve for their own workflows. Stuart, did you want to chime in a little bit more about the cookbook?
Yeah, absolutely. Only to say that, when we think about the FAIR principles in a general sense, of course, they are just that. They're a set of principles. So, as far as any discipline is concerned, we've got to work out, one, how do we implement that? And then two, how do we educate the community about it? So the cookbook is all about sort of trying to provide practical resources, not necessarily repeating what others already have available, but creating practical resources where chemists can really get up to speed with this area and kind of learn at least enough around sort of how you might go about making your data fair, or how you might think about setting up your data in the first place, as being fair, so that we can try and get the community oriented towards that, obviously earlier in the academic career of many chemists.
We have one more question in the chat. Considering the challenges for both and chemicals, so nanomaterials and chemicals, regarding the reporting and verification of methods, protocols, etc., would you think a joint case study to identify common grounds and approaches is possible? And any idea how that would look like?
Why not? I think some of that's actually already happening, maybe under, I think, it's like PARC, for example, you mentioned on one of your slides, Isolde, which is I can never remember all these things, Partnership for the Assessment of Risk of Chemicals and something like that. Thank you. That chemicals umbrella in that name is probably pretty broad and would include nanomaterials under that. So that's an example of where, you have this urgent need to understand how to track chemicals in the environment relative to their pollution risk on the one hand, and then trying to put together a whole view of how you document that. So that's one place that's already happening, is more at these, within these use cases like that. And I think that's something that IUPAC is trying to take away from that, is what is the common ground across those different use cases, so that so it can be incorporated into those basic and broad concepts that underlie that underlie our identification, our representation, our definitions.
Yeah. Just to pick up on that, I think TASOS in terms of WorldFAIR, because it is quite a short project, we're 1 year into the 2 years of it, we probably won't have the capacity to have a new case study. But you see in the arrangement of the petals in our flower which is just there behind Alex. You can see it. The idea was that the case studies are already kind of clustered. So, and chemistry, nanomaterials, and geochemistry, for example, are a cluster because we knew going in that we would have quite some overlaps. And I think part of our responsibilities over the coming year should be to try and, as we feed into the cross-domain framework, to really identify what those are and where things are similar, and where we can adopt things that have been developed in one community to the other with not too much reworking required. So I think it's really important, and it's definitely something we should pick up informally, even if we can't have another case study.
Yeah, I think I'd love to see also more practical, I loved your emphasis on the practical result. And I think for us, our given that it's a limited scope, we're focusing, in particular, as asked, on how IUPAC manages its standards. But there's so much activity happening. What do we need to do to enable the community on a more practical level? So I think if there were some opportunities for shared best practices for reporting, what does that look like?
And possibly as the nanomaterials community, we have been, you mentioned the Gold Book, for example. I'm not sure that nanomaterials chemists look at that all that often. So maybe that's an easy win that we could, and I know there probably is a project to update the terminology for materials going into the Gold Book. So that's maybe something that could be. But I mean, terminology, as we know from ISO and IUPAC and others, is one of those conversations that just never ends, right?
Yeah, and I think that's that working group on materials that's one of that's what they're trying to forward is, hey, look, we have this Gold Book for chemistry and it's got a lot in it. How can we enrich the terminology space around us for materials? Yeah, and in that sense, the chemistry is really playing a supporting role. So,
Thank you. We have about a minute left, and there was one question which I accidentally skipped. And Alex Henderson is asking, how can somebody get involved in those activities? So I've pointed Alex to the next RDA plenary, which is in October, and which is part of IDW, of course, and WorldFAIR will be there. But I was wondering if there is anything either of you would like to add. How can somebody get involved with everything you are doing?
Contact
us on the NINCHI standard. Once we have it in a shape that's ready for comments, feedback would be super, and examples of materials or cases would be amazing. So we can share that.
I look forward to that, Isel. Thank you.
I know, as I said, guilty conscience there, but
no worries. No, really, seriously. I just put the email. We have an email address. That might be a good place to start. And that way we can, think about what people's interests are. And there are other ways to get in touch with us as well. But that might be a start. And I think, Alex, what's the best way to get in touch with the project overall?
With the WorldFAIR.
WorldFAIR. Yeah.
So I will put our email address in the chat as well. But I think the best way is to follow us on social media and get our newsletter. I put an email address. Yeah.
For IUPAC, much of the activity is actually happening within the IUPAC project system. So this is the WorldFAIR is pretty much a high-level, broad strokes effort. And so if you have specific interests, there's probably a project or could be a project associated with it. So don't be shy.
Excellent. So we are 1 minute past the hour. Thank you both very much. And thanks to our attendees for being here, for your questions and the interesting conversation. I think we can wrap up.
Thank you, everyone, for staying with us.
Thank you all.